In chemistry, the pH of a solution is the measure of the acidity of the solution. The definition for pH involves common logarithms, or log base 10. pH equals negative log base 10 of H+, where H+ is the concentration of the hydrogen ion in moles per liter. The range for pH is from 0 to 14. Pure water, a neutral solution, has a pH of 7. An acidic solution, such as vinegar, will have a pH less than 7. And an alkaline solution, such as ammonia, has a pH above 7. Number 1. Normal rainwater has a pH of 5.6. What is the concentration of the hydrogen ion in normal rainwater? Well, this one, they give you the value pH, and they want you to look for H+. So let's use the formula that's given to us. pH equals negative log base 10 of H+. All right, and now let's plug in the value 5.6 for pH. So you have 5.6 equals negative log base 10 of H+. And then I'm going to switch the negative sign. So the negative sign, because, I want to put it in this format. Y equals log base B of X. And as you know, there are no negative signs right here. So if you do have a negative sign like here, you're going to put it on the left-hand side. Or, you could divide both sides by -1. It's the same thing. So we're going to put negative 5.6, and then on the right-hand side will be log base 10 of H+. And then we're going to do the swap. So we're going to swap negative 5.6 and the H+. After swapping, we will have concentration of the hydrogen ion equals 10 to the negative 5.6. If you use your calculator to calculate this, the right-hand side is approximately 2.5 times 10 to the negative 6, and the units, moles per liter. So that will be the answer to number 1. Let's look at number 2. The concentration of the hydrogen ion in a sample acid rain known to kill fish is 3.2 times 10 to the negative 5 mole per liter. Find the pH of this acid rain to the nearest tenth. So again, we are going to use this formula, pH equals negative log of H+. Whenever you don't see a base like this one, the base is 10, because base 10 is a common logarithm. So I would suggest that you put that 10 as the base. And then let's plug in. This time, that 3.2 times 10 to the negative 5 is not pH, it's the concentration of hydrogen ion. So you're going to copy the rest of the equation and replace that H+ with 3.2 times 10 to the negative 5. And I will put a grouping symbol right there. So this is the equation that we have. And just like before, we're going to put that negative sign to the left. So negative pH. Oh, actually, we don't need to, right? We don't need to. We could just use your calculator to calculate right now what it is, because, pH is what we need. So you just use your calculator to calculate. So on the right-hand side, you enter negative log base 10 of 3.2 times 10 to the negative 5 on your calculator. And if your calculator does it correctly, you should get approximately, before we reveal the answer, you should have an expectation, right? Because this is an acid rain. The pH is less than 7. So you should get a number that's less than 7 and between 0 and 14. If your number is not that, then you probably did something wrong. So for this one, if you did everything correctly on the right-hand side, you should get approximately 4.5. And by the way, the question did say round it to the nearest tenth, so you keep 1 decimal place. And that is the pH of that rainwater, which will kill fish, 4.5.